This video goes with your notes guide for section 5.5, building the inverse of a function. It says here that the inverse of a relation is found by exchanging the x and y coordinates of all points or exchanging the x and y variables in an equation. And it gives you a notation for the inverse as well. We'll talk more about the notation in class tomorrow. I'm not that worried about what I'm highlighting right now in yellow for the purposes of this video. Again, we'll go over that in class the next time we meet. As for what we see here in green, exchanging the x and y coordinates, that's what we did during the investigation today. If you were in class and you participated in the investigation, this was when we found the table of values for the original function, and then we flipped the x and y's around and graphed to find the inverse. Today, what we're going to focus on is what I'm highlighting here in blue, exchanging the x and y variables in the equation. So you can see here in example A, they start us off by giving us the equation f of x equals 4 minus 3x. And the first thing that I want you to do is I want you to go back to the old days when we had y instead of f of x. It's a little bit easier to manage and to manipulate in the process that we're about to do. Next, it says in blue, exchange the x and y variables in an equation. So what you're going to see me do here is take this x and y and have them trade places. That is the main step in solving for an inverse. Okay, so we're going to go ahead and instead of y equals 4 minus 3x, we're going to make it x equals 4 minus 3y. So in other words, x and y are trading places. Then we're going to try to isolate the variable y. So we're going to work backwards to get that y by itself. So I'm going to take away 4 from both sides. And we get x minus 4 equals negative 3y. Notice I did not add 4 to both sides. Many students will see this subtraction sign here, and they'll think, oh, we have minus 4, so I'm going to add 4. That is incorrect. Please don't do that. That negative sign belongs to the 3y, and you can notice that it still exists here in my equation. So the 4 is positive, so we subtracted it from both sides. Next, we're going to divide both sides by negative 3. So we get x minus 4 over negative 3 equaling, these cancel, y. So we now got y by itself, and that is the inverse of the original function that you see in black. One other step will be involved, but for now, let's just take a look here. We have y equals 4 minus 3x. The inverse is y equals x minus 4 divided by negative 3. If we think about it in terms of if you were x, the first thing you would do is you would multiply by negative 3, and then you would add on that 4 that you see there. So you would multiply by negative 3, and then you would add 4. If we think about what an inverse is, it's taking these two steps and working backwards and doing the opposite. So now in the inverse, the x, instead of adding 4, you do the opposite and subtract 4. Instead of multiplying by negative 3, you do the opposite and divide by negative 3. So that is the inverse for example A. And we'll talk more about the notation that I mentioned up here in yellow tomorrow. Next, let's move down and let's work on, instead of moving to example B, I'd like you to actually go down to the examples at the bottom of the page on the handout. And let's just practice finding the inverse for these functions. This little b is in the wrong place. On my handout, it should be over there. Okay, so step 1 for A. Use y instead of f of x. We have x minus 2 squared minus 5. Okay. Next, we're going to let x and y trade places. Step 1 in finding the inverse, x and y trade places. Then we're going to try to isolate that y, get that y by itself. So first, I'm going to add 5 to remove that minus 5. So you get x plus 5 equals y minus 2, the quantity, squared. Next, we're going to do the opposite of squaring, and that is to square root both sides. So the left side will be the square root of x plus 5, the whole thing, equaling the square root cancels the square, and you're left with just y minus 2. Finally, to get y by itself, you're going to add 2 to both sides, and you get y equals the square root of x plus 5. Now that square root shuts down there, and then you have the plus 2. Again, that comes from this 2, this minus 2, adding that 2 to both sides. That's my final answer. That is the inverse. And I'm going to put a star next to this one because there's a bit more discussion that we need to worry about here. And that is, it has to do with the original function being a parabola and its inverse being a half parabola. So this is one of those, if you were here for the investigation, it's going to involve restricting the domain of the original so that the inverse exists. More on that tomorrow, or the next time we meet. For part B, we have y equal to the square root of x plus 4 minus 3. Step 1, in every inverse, switch x and y. X and y trade places. Next, isolate the y by working backwards. That plus 3 is going to be removed. Sorry, the minus 3 is going to be removed by adding 3 to both sides. So we get x plus 3 equals the square root of y plus 4. Then we're going to undo the square root by squaring both sides. The left side is going to be the entire quantity squared. So you have to put the x plus 3 in parentheses and square it. That equals y plus 4. The squaring cancels the square root. Finally, subtract 4 from both sides. So we have x plus 3 squared. Take away 4 from that. There's your inverse. This is another case where we're going to star this because, sorry, wrong one. We're going to star this because we're going to have to discuss how to restrict the domain on this. The original function is a square root. The inverse is a parabola. So there are some issues there that we're going to discuss the next time we meet. What I would like you to do next is I would like you to take C and D and work on them on your own. Pause the video and see how you did. I'm back, and here we go. We have C and D complete for you. You can see all my work is done here. I switched x and y. I then multiplied both sides by 3. Then I added 6 to both sides. I had y minus 6. You do the opposite, and you add 6 to both sides. So the final answer is going to be y equals 3x plus 6. That's the inverse. In D, started by switching x and y. So the y and the x trade places. Trying to then isolate the y, we remove the cube root by cubing both sides. That's where this x cubed comes from. Then you have a 5y because the cube cancels the cube root. To get rid of the 5y, you want it to just be y. You divide both sides by 5. And we have our final answer. Oops. X cubed divided by 5. That concludes the initial examples for section 5.5. Hopefully you followed that. If not, we will recap it the next time we meet in class. We have another day of lesson 5.5, and we will discuss not only these examples, but we'll look at example B from the previous page, where they ask you to then find the composition of the function with its inverse. Again, we will explore that as a group. and then you will have some problems to work on to practice this. Any questions, feel free to email or comment on the video.